All right, my AB kids, here comes section 5.5 on absolute extrema for candidates, from candidates. So here's what they're really looking for. They're giving you fancy pants math words, but they're really looking for where is the absolute maximum or the absolute minimum. And what they're doing this time is they're chunking off a piece of the graph and not looking at the entire graph. So for example, you could have a picture that looks something like this. Starts at this place, comes down, does a little thing here, goes like this. All right, there it is, and ends over here. So I have two endpoints. So far, when I've been looking at these things, I have not had an endpoint. So that's what makes this different. And then I can see that this point here would be a critical point. We've talked about those earlier. And this point here would actually be also a critical point. So critical points give us the possibilities of finding a maximum or a minimum, where the ends of the interval, the endpoints, give us another possibility for finding a maximum or a minimum. And what they're going to do is they're going to oftentimes ask for it this way. They're going to ask for a maximum value. They use this word value. And that's how you know you need to be looking at it in this respect with those endpoints, minimum value. And that just means that they're looking for what the y values are for these. What's the y value? What's the tallest or the smallest y value for the function? So if I look at the picture that I've got here, the absolute maximum value would be this point up here at the critical point. That's the highest point of all. But the lowest absolute minimum would be this point over here because he's the lowest overall. So one of them happened at a critical point and one of them happened at an end point. And that can be the case with these things. So it's either going to happen, your maximums and minimum values are going to happen either at a critical point or an end point. So candidates for the absolute extrema on an interval are either going to be critical points or endpoints. All right, so find the absolute maximum, see they use the word value, and the absolute minimum value of the function here on the interval, and they have to give you an interval with these from -1/2 to 4. Remember to show that you checked all the candidates. So all the candidates mean I've got to find the critical points and I've got to find the endpoints. So here we go. Critical points. Let's go for them first. Remember from previous lessons, to find a critical point, you are taking the derivative. (3x² minus 6x), and I'm setting it equal to 0. And solving for x. Now in the previous sections, we've actually also, is this ever undefined? Because I also want to do that. Critical points are when you set it equal to 0 or when the first derivative is undefined, which it isn't. How do I know that? Because it's a parabola. It's an x² function, so it's quadratic. It doesn't have any issues. All right, so what you're going to do is, in the previous sections you were making sign charts from here. You don't have to do that for these. These are looking for what the values would be, the y values, and you're going to put these back into the original function. I want to know what the tallest and smallest y value is for this function. And what I'm going to put on there is my starting place of -1/2, and then I'm going to put my critical points, 0 and 2, and then I'm going to close it up with whatever 4 is. Now I'm putting these into my original function. The easiest way to do this, if it's a calculator question, is to put this in your y1 and then go to the table and input these values. I mean, for a -1/2, it gets a little bit messy in the midst, but it comes out to be, I'll tell you what they come out to be, 0.125. 0 would be easy enough to put in, you get a 1 out. 2 isn't bad. If I plug a 2 in, I get a -3 out. And if I plug a 4 in, I get 17 out. And so then the question is, who is the absolute maximum? And we can see that the highest y value is here. So I have an absolute maximum value of 17. That's the highest of all. My absolute maximum value, find the absolute maximum value, and my smallest y value is this guy. He's going to be, got a little extra lump in there. He's going to be my absolute minimum. Did I say that right now? Minimum value of -3. You'll see a lot of times I just write it as the coordinate, 2, -3, and 4, 17. But realize when they're asking you for the absolute minimum value, they're really looking for what the y values would be. All right, then we get to the second example here from a graph. This one gets a little bit more tricky. You got to almost think of this more logically than we do most problems. So looking at this is the graph of the first derivative. We can identify relative extrema at the x-intercepts. Can you find the x-coordinate of the absolute maximum and the absolute minimum? All right, so I'm going to use a highlighter here to kind of separate these things. I have values here that are all above the x-axis. And I have this little piece here that's also above. So those two pieces are above. This little guy here is my piece that's below. Now, why is that important? If I'm looking at the first derivative, and the first derivative is positive, f prime of x is greater than 0, for this whole blue part, that means that the graph is increasing for the function. The original function, f of x, is increasing. Where down here, my yellow part, my first derivative is below the x-axis, so it's negative. That means my function is decreasing. And then it goes back to increasing again, this little blue piece, right? Now think about this logically. If I start at a starting place and I'm increasing until I get to here, and then I'm decreasing a little bit, compared to all this part versus this part, it's doing more increasing than it is decreasing. And then it does a little itty-bitty part of increasing again. And so the question is, where do I have the absolute maximum? So if I'm thinking about this logically, if my graph increases till here, that's a whole lot of increasing going on. And then it does a little decrease and a little increase. So at this place here, it's done the most increasing. If it's done the most increasing, then that means that it has to be your maximum. So you have an absolute maximum at x equals 1. And again, thinking logically, if I look at this where it's decreasing, this little piece here is decreasing, but how far did it decrease? Did it decrease as much as it increased over here? And the answer is no. This did a whole lot more increasing than decreasing of this little place here. So where is the absolute minimum? And the answer is over here at -3. Because remember, it started at this low place, and then it increased for this whole big time, and then it decreased, but not as much as it increased. So that means it went down, but it didn't go down as low as what this guy, where it started from, was. So you have an absolute minimum at x equals -3. I know that that's kind of an odd question, but that's what you're looking at for that guy. All right, that, my friends, is it for the notes. Let's try a couple example problems. I chose number 4 as one of mine. So let's take a look at number 4. It says, find the absolute maximum value and the absolute minimum value. And again, the word value tells you you're looking for the y coordinate of the function over the interval. Make sure that you've checked all the candidates. All right, so I have to find the critical points first. Critical points take the first derivative. F prime of x is, derivative of sine is cosine of x plus pi over 4 times the derivative of the angle, but that's just a 1. And so there you go, there's my first derivative. Is it undefined anywhere? And we say, nope, it's the cosine graph. He waves. He's happy all the time. All right, so I'm going to set that first derivative equal to 0. Well, I've got a funky angle, but I need to know where cosine equals 0. So I'm going to go around my unit circle, thinking about my unit circle, and I'm only going, by the way, between 0 and 7 pi over 4, and I want to know where do I get an x value of 0. And you should say at pi over 2 and at 3 pi over 2. Well, that's what this angle has to equal, x plus pi over 4. Well, if I take a quarter and I take it away from a half, I'm left with a quarter. So pi over 4 is one of my x values. If I have 6 pi over 4 and I take a pi over 4 away, I'm at 5 pi over 4. Okay, now I'm going to make a table of values. On my table of values has to go the x endpoints. So I start at 0, and then I have my critical points of pi over 4, 5 pi over 4, and then I have 7 pi over 4 to close it up with my other endpoint. Now I'm going to go to, I can either go to my handy dandy calculator or I can think of the unit circle, whichever way you want to go. If I plug this in, now remember I'm plugging it back into the original. This is going into f of x. If I put a 0 in there, the sine of pi over 4 is the square root of 2 over 2. If I put a pi over 4 in there, pi over 4 plus pi over 4 is 2 pi over 4, pi over 2. The sine at pi over 2 is 1. If I put a 5 pi over 4 in there, now I'm at 6 pi over 4. So that would be 3 pi over 2. The sine of 3 pi over 2 is a negative 1. And if I put a 7 pi over 4 in there, I get 8 pi over 4. That's 2 pi. The sine of 2 pi is 0. They want me to figure out where the absolute maximum value, that would be the highest overall. Well, the highest overall, this, by the way, is 0.707. So 0.707, 1, negative 1, and 0. The highest overall is pi over 4. So that would be at x equals pi over 4. So it would be the coordinate pi over 4, comma 1. But remember, it's the y value, so you could also say the absolute maximum value is 1. That particular y value. And the absolute minimum value is the lowest of all, which would be this guy here. So it turns out your two critical points this time were where they were located. That is not always the case. Sometimes it's the endpoints. So there's one with a little trig going on. Let's see what else I picked here. So if I look at the graph again, number 7, like that graphing one that we talked about a little bit ago. If I look at, this is a positive first derivative, this is a negative first derivative. And so I'm looking at where do I have the most positive, the absolute maximum, the most positive space would be at 0. So my absolute maximum is at x equals 0. Where my absolute minimum, where do I have the most negative space? That would be down here at 3. A little odd, but that's what it is. And then I think that might be, oh no, one more I picked. Number 12. So number 12, the particle moves along the x-axis with the position given by e to the negative t. Find the time at which the particle is furthest to the right. In other words, it wants to know the absolute maximum value. When is it furthest to the right? So I find my first derivative for my critical points. Ooh, product rule. Okay, so e to the negative t times derivative of cosine is a negative sine plus cosine of t times the derivative of e to the negative t, which is a negative e to the negative t. This one gets kind of ugly. Let me see if I can make it any better. I'm going to set it equal to 0, and I can see that there's two terms and they both have a negative e to the negative t. If I factor that out, that leaves me with the sine of t plus the cosine of t. So either negative e to the negative t equals 0, or the sine of t plus cosine of t equals 0. Remember, in order for this to equal 0, one of these two pieces has to be a 0. If I think of the e graph, it's an exponential graph. It asymptotes at 0, so there is no value where it equals 0. And this is a little more complicated to think through. It would be different if these were squares, because remember, that's a Pythagorean identity. You'd end up with sine squared plus cosine squared is 1. But we don't have that. So here's what I'm going to think on this one. If I have the sine of t and I move the cosine to the other side, think of the unit circle and all the coordinates around the unit circle, so that I want them to be the same value, but I want them to be opposite signs. So if I think of the coordinates are like 0, 1, 1, 0, 1 half, square root of 3 over 2, or square root of 2 over 2, square root of 2 over 2. Bingo, that's the one. They're the same value, but they have to be opposite signs. So where does that happen? If I'm at pi over 4, they're both positive. If I go around to the next quadrant, quadrant 2, at 3 pi over 4, one of them is positive and one of them is negative. That fits. If I keep going around in the third quadrant, they're both negative. That doesn't fit. And if I go to the fourth quadrant, now I'm at 7 pi over 4, and now I've got one that's positive and one that's negative. All right, there's my critical values. I'm going to make my table. I know I start at 0 from my piece here of domain. I know I have a 3 pi over 4, I have a 7 pi over 4 as my critical values, and I'm closing up at 2 pi. So I'm going to go to my calculator, and I'm going to put it, remember, I'm putting it into the original function. So put in e to the negative t times the cosine of t, and see what your values come out to be. 0 gives me 1. 3 pi over 4 gives me a negative 0.067. This is totally from the calculator. I have 0.003 and 0.002. Question says, find the time when it's farthest to the right. I want the absolute maximum value. When is it farthest to the right? That would be at this guy right here. So that would be, what do they want? At time t. Find the time. So at t equals 0, it is farthest to the right because that gives me the biggest y value, which is a 1. All right, that takes care of section 5.5 on absolute extremis. So find critical points, make a table of values, make sure you remember to put them back into the original function because you want to know where the original function has the tallest y value or the smallest y value. Shoot me an email if you have questions.